Today's article is relationship between a phase angle and path or path difference. On that, the question will be asked like this: obtain relationship between phase angle and path difference. The relation for this we can answer like this: by solving some of the examples which we have learned yesterday, we get the relationship between the phase angle equal to 2 pi by lambda into path length. Now suppose that the phase angle is delta phi, that is equal to 2 pi by lambda into path length is delta L, or path difference. Here I will take path difference. But this delta L, that is the path difference, we have obtained yesterday, that is YD upon capital D, small y into D upon capital D. Put this value in this equation. So delta phi equal to 2 pi by lambda into YD upon capital D, and this is the expression for, or this gives the relationship between the path length and phase angle. This is relationship between phase angle and path difference. Now if we consider the for constructive interference in terms of phase difference, for constructive interference, the phase difference is given by this phi n equal to, or delta phi n equal to n into 2 pi, where n equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. This n, it is the integer. Next, for destructive interference, for destructive interference, the phase difference is given by delta phi n equal to n minus half into 2 pi, or this is also equal to twice n minus 1 into pi, where this n equal to plus or minus 1, plus or minus 2, plus or minus 3, and so on. So this way we can obtain the relationship between phase angle and path difference. The next article will be the intensity distribution. Manual, for the interference, it requires minimum 2 sources of light. Next, if these 2 sources of light, they are having same amplitude, then the resultant amplitude, it is twice the amplitude, or 2 times A. Again, if we obtain the resultant intensity of the resultant wave, then it will be 4 times the intensity of initial source. And therefore, this intensity distribution that plays very vital role in the interference. And the same thing we are going to learn over here. For this purpose, the expression will be show that for a interference pattern, consisting two sources of equal intensities, the resultant amplitude the resultant amplitude will be resultant intensity, we can say, is 4 times I0 sine square 4 times I0 into cos square phi by 2. Now to answer this, consider two sources of light. Remember the figure for analytical treatment. In that we have shown the two sources S1 and S2. Again on the screen there is one point P. Now at this point P, if these two sources are emitting the intensities of equal magnitude I0, then at point P, for constructive interference, the resultant intensity will be 4I0 into cos square phi by 2, where phi is the phase angle. Now here we are going to consider two sources of light. Suppose E1 is the simple harmonic wave which emits the light from the source S1, and that is equal to E0 sine of omega t. Again, E2 is the equation of the wave emitting the light from the source S2, that is equal to E2 equal to E0 sine of omega t plus phi, where this phi is the initial angle between these two sources. Here the amplitude is E0, amplitude is E0. Next, here the amplitude is same, and therefore we know the intensity of light, it is directly proportional to amplitude square. And therefore, if we consider I0 as intensity, it is directly proportional to E0 square. But here, these two equations, they differ in phase, and that's why we will obtain an equation for resultant wave. So, the expression for resultant wave will be E equal to E0 sine phi or E0 sine omega t plus E0 sine of omega t plus phi. Now here E0 it is common. E0 in bracket sine omega t plus sine omega t plus phi. Using sin c plus sin d, we write this E equal to resultant equation of the wave. This E equal to, in short I will write, that is equal to twice E0 cos of phi by 2. Into sine of omega t plus phi by 2. This is the equation. This is the equation for the resultant of these two waves. Here these two waves, they are going to superimpose with each other, and after superimposition we are getting a resultant equation. Now, the amplitude of this wave, it is the amplitude of resultant wave is twice E0 cos of phi by 2. Twice E0 cos of phi by 2. It means this is the amplitude. Next, we know that the resultant intensity I0 directly proportional to or amplitude square. And therefore this I0 directly proportional to twice E0 cos of phi by 2 whole square, that is nothing but 2 square, it is 4 E0 cos square phi by 2. But what is E0 square? This E0 square, it is I0, and therefore it is, or here I'll write the intensity I equal to, or I is directly proportional to 4 times I0 cos square phi by 2. Hence proved. So this way, this is the intensity distribution of the two waves when they are emitting light in terms of intensity.